Hello again, and welcome to Recording 1D on our series about angles and standard position for Unit 2, Chapter 2 of Trigonometry and Mathematics 2200. In this recording, we'll be focusing on the development of the 30, 60, 90, and 45, 45, 90 triangles, and how we can use those for determining the exact values of cosine, sine, and tangent for 30, 45, and 60 degree angles. We'll have a look at a demonstration now in a moment for this development on the 30, 60, 90 triangle, but the steps for your records are outlined here as well. To develop the basic 30, 60, 90 triangle, we begin with an equilateral triangle of side length 2 units each. Each angle of the triangle is obviously 60 degrees. We find the midpoint of the base and draw the perpendicular bisector from the top of the triangle down to the base. That gives us two congruent triangles. Now we have each small angle of the triangle of the small triangles right in here. That is a 30-degree angle. So we'll put 30 degrees right there. And now we have our 30, 60, 90 triangle if we simply hide the right side of the original triangle. In other words, take your eraser and rub it out. Of course, that bottom side is no longer a 2, so we're going to have to swap that out. And because it's only half of the original base, now it's only 1 unit long. The only other thing we have to do here is determine the length of that original perpendicular bisector, the height of this triangle. So we'll label that as B, and because it's a right triangle, we can now use our Pythagorean theorem. We have 1 squared plus B squared equals the hypotenuse squared. Doing a bit of rearranging, we now have B squared equals 2 squared minus 1 squared. So it turns out that B squared is 3, and therefore B is equal to the square root of 3, which we can now label on our triangle. That's our basic 30, 60, 90 triangle. You should memorize those side lengths. Once again, the steps are recorded here for you. Next, we develop the basic 45, 45, 90 triangle. It's a little easier to develop this one. For this triangle, we recognize first of all that we have two equal angles, 45 and 45. So that makes this triangle isosceles. It's also a right. There's also a right angle right here, so it is a right triangle. Because it's an isosceles triangle, we have two equal sides of 1 and 1 across from both of the 45s. Therefore, in this triangle, the unknown measurement is the hypotenuse. Once again, we can apply our Pythagorean theorem, recognizing that it's now 1 squared, this leg squared, plus this leg squared, another 1 squared equals c squared. So that gives us 1 squared plus 1 squared is 2, so c squared is 2, and therefore c is equal to the square root of 2. And we can label that now on our triangle, like so. Once again, make sure you memorize the side lengths of this basic 45, 45, 90 triangle. And once again, the steps in that demonstration are recorded here for you, so I won't repeat those again. You may be wondering why we want to even interest ourselves in the basic 30, 60, 90, and 45, 45, 90 triangles. Well, for one reason, we would like to be able to find some exact values for the cosine, sine, and tangent of 30 degrees, 60 degrees, and 45 degrees. And we'll do that by using these triangles. First of all, you may recall that the cosine of an angle is equal to the adjacent side divided by the hypotenuse. The sine of an angle is opposite over hypotenuse. tan is opposite over adjacent. So if we look at this basic 30, 60, 90 triangle, the cosine of 30, the adjacent side to the 30-degree angle is the root 3, and the hypotenuse is 2. The sine of 30 degrees is the opposite over the hypotenuse, that's the 1 over the 2, and the tan of 30 degrees is opposite is 1, hypotenuse is root 3, or adjacent rather is root 3. The cosine of 60 degrees, the adjacent for the 60-degree angle is now the 1, and the hypotenuse is 2. The sine of 60 degrees, opposite is root 3 for the 60-degree angle, 2 for the hypotenuse. The tan of 60 degrees is opposite, which is root 3 over 1. And of course, because we're only dividing by 1, that can be simplified to just the square root of 3. 45-degree angle, we have to go to the other triangle. The cosine of 45 degrees is adjacent. And you know, it doesn't matter if we go by this 45-degree angle or this one, because the adjacent leg for each of those angles is still 1 unit long. The hypotenuse is root 2. And similarly, the sine is the opposite side for either 45-degree angle, so that's a 1, and the hypotenuse is root 2. The tan of 45 degrees is opposite, which is 1, adjacent, which is 1, which gives us 1 over 1 is equal to simply 1. In summary, for the basic 30, 60, 90 triangle, the lengths of the sides are 1, root 3, and 2, and you should memorize those lengths. For the basic 45, 45, 90 triangle, the sides are 1, 1, and root 2. Make sure you memorize those. And these basic triangles can be used to find the exact trig values for 30, 45, and 60.